Okay, welcome Metro High School Algebra 2 students. This is the Unit 2 Midterm Remediation. So let's get into it. So as we look at this first question, right, we're looking at the equation y equals the quantity of x minus 3 all squared minus 1. And the first thing we're asked to do is find the x-intercepts. So I'm going to move this to a clean page. So the first thing we want to do when we find the x-intercepts is we want to set y equal to 0. Okay? So now we've done this, and there's two ways you can proceed from here. You can either FOIL out this expression, or we can just do this. We can add 1 to each side. Then we can take the square root of each side. And remember, when we take the square root, it has to be plus or minus, right? Okay, and then we're left with plus or minus 1 equals x minus 3. So x equals negative 1 plus 3 equals 2, and x equals 1 plus 3 equals 4. So our x-intercepts are x equals 2 and 4. So that's the answer to part A. And then now we want to find the y-intercept. And so similarly to what we do to find the x-intercepts, we do a similar thing, except instead of setting y equal to 0, we set x equal to 0. So we take our equation, right? We have this. Now we want to set x equal to 0. So we'll get y equals 0 minus 3, quantity squared, minus 1. Or y equals negative 3 squared minus 1. And what's negative 3 squared? That's 9 minus 1, 8. So our y-intercept is y equals 8. Now, we're looking to find the coordinates of the vertex of this equation. So to do this, we need to know what a and b are when we expand this expression. So let's do that. So we can look at x minus 3 quantity squared, and an easy way to expand that is we can square the first term, then we can multiply negative 3 times x and double, and then square the last term. And then our minus 1 is still there, equals y. Okay, so now to find the coordinates of the vertex, we have our neat formula, right? X equals opposite b all over 2a. Okay, so in this case, b is negative 6, a is 1, so we're left with x equals negative 6 all over 2 times 1, which is equal to 6 over 2, or 3. Okay, so that's the x-coordinate of our vertex. Now we need to find the y-coordinate. How do we do that? Well, we know what x equals, so let's put that into our equation and solve for y. So y equals 3 minus 3, quantity squared, minus 1. And 3 minus 3, that's just 0. So y equals minus 1. So the coordinates of our vertex are 3, negative 1. Now to graph this, we know our y-intercept. So x equals 0 and y equals 8. That's going to be right here. And now we have two x-intercepts at 1, 2, and 3, 4. And then now we should graph our vertex, which is at x equals 3. So we're in between 2 and 4. And then y equals negative 1. So about right here. And then the graph of our parabola will look something like this. All right, now let's take a look at problem number 2. Okay, let's take a look at problem number 2. So problem number 2 gives us this equation, and we're going to solve for x. So let me write this down. And then move it to a blank page so we have more room to work. Okay. So we have this equation, and we're going to solve for x. Now in my brain, it makes more sense to move all of these over to the other side so that our leading coefficient isn't negative. That looks cleaner to me. So we'll have 0 equals x squared minus x minus 20. Okay, and then now to factor. So if we remember how to factor, we look at the sign on C, right? It's negative, so we know we're going to have an x plus and an x minus. And then we want to look for two numbers that multiply to get 20 and then add to get negative 1. Okay, so what are some factors of 20? We have 20 and 1, 10 and 2, 4 and 5. Oh, and I can stop right there because 4 and 5 are only one number apart. And a little trick is you can look at the sign on B and know that your bigger number has to go there. So this is our factored form of the equation. Set it equal to 0. And so now solving for x becomes simple. We just said each of these equal to 0. So x plus 4 equals 0. We have that one solution is x equals negative 4. And then x minus 5 equals 0. We have that the other solution is x equals 5. So we go up to write our answers. X equals negative 4 and 5. All right, now let's take a look at number 3. And so for number 3, we're presented with this inequality. 4x squared minus 12x plus 9 is less than or equal to 0. And the first thing we want to do is factor. We want to factor this this inequality. And okay. So how do we do this? Well, remember the A times C method, right? Where we'll put A times C up here and then B down here. So what is A times C? Well, 9 times 4, that's 36. B is negative 12. So we're looking for two numbers that add to get positive 36 or multiply to get positive 36, sorry, and then add to get negative 12. So we can look at some factors of 36. We get 36 and 1, okay, 6 and 6, that sounds promising, and 12 and 3, and 4 and 9. Now, the only one that works is 6 and 6, and they both have to be negative, so that's what we get here, minus 6, minus 6. So we can rewrite this equation as 4x squared minus 6x minus 6x plus 9 is less than or equal to 0. Now, we want to look at each of these, and we want to pull out a common factor from each. Okay, so the common factor from our first equation can be 2x. What we want to do is find a common factor for each of these. So, looking at 4x squared minus 6x, our common factor can be 2x. Then we're left with 2x minus 3. And then, as we look at this second set here, our common factor can be negative 3. So, negative 3, then inside we'll just have 2x. And then, since the sign changed, minus 3. And what do we notice here is that we can pull out this binomial, 2x minus 3, and then we're left with another 2x minus 3. This is all less than or equal to 0. I apologize. And since these two are the same, that's the same as the quantity of 2x minus 3, all squared, less than or equal to 0. And so that is how we factor this inequality. So, part B asks us what we can conclude about the inequality. So, let's look at A. Will the inequality have two solutions? Well, let's think. If this were an equal sign, how many solutions will we have? Right, we just have one because when we square it, we'd just be left with 2x minus 3 equals 0. So we'd just be left with x equals 3/2. So C is correct here. There will only be one solution. And then I will leave part C for you guys as an exercise to check your understanding. Okay, and now we're on to part 4. In a room of n people, if everyone shakes hands with everyone else, the total number of handshakes is given by n times quantity of n minus 1 all over 2. If 780 handshakes are made, how many people are in the room? That's cut off, but that's what it's asking. So we can look at this, and this gives us a number of handshakes, and we're also given a number of handshakes. So in my mind, that means we want to set this equal to the number of handshakes. And we're going to find out how many people are in the room. So to get n by itself, what should we do? So I'm going to multiply by 2 on each side. Then I'm left with n times n minus 1 equal to, well, 780 plus 780, 0, 6, 1560. Okay, and now I'm going to distribute this n across. So we get n squared minus n is equal to 1560. Now to solve for this, I'm going to use completing the square. So if we remember back to completing the square, we can rewrite this as n squared minus 2 times a half times n. And then what we want to add to the equation is half of b squared. And so 0.5 squared is 0.25. And then since we added that to the one side, we have to add that to the other side. Okay, so we're left with this. Then we can factor as n plus 0.5 squared, and this is by convention of completing the square, equals 1,560 and a fourth. Then we take the square root of each side, and we're left with n plus 0.5 equals plus or minus 39 and a half. But since we're trying to figure out how many people are in the room, we are going to just use the plus because there's no such thing as negative people. So now we're going to add, this should be a minus here. So now we're going to add 0.5 to each side, and we get n equals 40. And so that is the solution to problem number 4. Then we're going to take a look at problem number 5. Okay, problem number 5. Consider the function y equals x squared plus 6x plus 5. Determine the equation of the axis of symmetry. And we already did this on a previous question, right? And we remember that to find the axis of symmetry, we use x equals opposite b over 2a. So we look at our equation. B is 6. So x equals negative 6 over 2 times our a is 1. So 1, negative 6 over 2. And we can see that that is negative 3. So that's our axis of symmetry. So by looking here, we can tell that this parabola is concave up, right? So by finding our axis of symmetry, we're really finding the minimum of this graph. And so to find the minimum value of y, all we have to do is take our x value and substitute it back into the equation. So y equals negative 3 squared plus 6 times negative 3 plus 5. So y equals 9, not plus, minus 18 plus 5, negative 9 plus 5, y equals negative 4. Okay, and so since we found the x value and the y value, we know that the coordinates of our vertex are negative 3, comma, negative 4. That's our vertex. Now we're going to analyze this other graph here. And first it wants us to find its vertex. So we go down here and we see that here's the vertex, and then we count 1, 2, 3. Okay, but that's to the negative, so x is negative. And then we look for the height, and we look that the scale is different, right? This goes by 2. So 2, 4, 6, 8. So the vertex is -3, comma, -8. So part E, which of the following are common to the graph of y equals x squared plus 6x plus 5 in the graph provided? Let me remove this page in between there so we can look at the options. Okay. Do they have the same concavity? Well, yes, we determined that, right? Because they both open up. So A is right. And we're selecting all that apply. Make sure you read that part. Okay. Do they have the same x-intercepts? Well, let's find out. An easy way to check that is to first look at this graph, and we see that its x-intercepts are -5 and -1. So we put those into our equation, and we determine if y equals 0 at that point. So y of -1, -1 squared, plus 6 times -1 plus 5, y equals 1 minus 6 plus 5, y equals -5 plus 5 equals 0. So we know that -1 works. And now we're going to test -5. So y of -5, -5 squared, plus 6 times -5, plus 5. So we're left with 25 minus 30 plus 5, -5 plus 5 equals 0. So that one also works. So they do have the same x-intercepts. Now this one asks, do they share the same turning point? Well, that's the same as asking if they have the same vertex. So look at the coordinates for this vertex is -3, -8. And this is -3, -4. So no, they do not have the same turning point. So A and B are correct, and C is not. Now we're on to number 6, the last one. Let's take a crack at it. So part A. Find the x values of the x-intercepts. Okay, so when it asks us that, all we're going to do is set y equal to 0. So we have 0 equals x minus 5, quantity squared, minus 1. And then now we want to solve for x. So we add 1. 1 equals x minus 5, quantity squared. And now we have to take the root of each side. Remember, we get a plus or minus. And we get an x minus 5. So x equals +1 plus 5. Or, no, not or, and x equals -1 plus 5. So x equals 6 and x equals 4. So x equals 4, 6. That's the answer to A. Okay. Part B. Find the y value of the y-intercept. So now we have to set x equal to 0. So let me break this up. Okay. Y equals, setting x equal to 0, minus 1. So y equals -5 squared minus 1. So y equals 25 minus 1. So y equals 24. And take that, write that where it goes. Okay, now we're asked to find the coordinates of the vertex. So remember, we need to know what B and A are in this case. So we can expand the squaring of the binomial, right? So we square, multiply and double, and we square again, and then we still have our minus 1, and then we know that x equals opposite B over 2A. So in this instance, B is -10, so x equals +10 over 2 times A. A is 1, so 10 halves, which is the same as 5. So x equals 5. Now to find the y-coordinate of the vertex, we have to substitute in 5 for x. So y equals 5 minus 5 squared minus 1, or y equals -1. That's our vertex. So now we have to graph the equation. So here's our graph right here. And remember, the coordinates of our vertex are over 5, okay? And then down 1, because y is negative. So right here's our vertex. And then now we're going to look for our y-intercept, which is 24. So 1920. This scale is 1. So we just imagine we go 4. 1, 2, 3, 4. So we'll call this our y-intercept right here. And then now our x-intercepts are at 4 and at 6. So here's 4, here's 6, and then we can sketch our parabola, and that is the answer to number 6, and thus ends our remediation.